Good evening, everyone. Welcome to this our class. We've gone some distance in this class, so we are in our third script, and we are delving deeper and deeper into uh, R, the use of R in data analysis. So I missed last week. There was a lot of work in the lab. I was wondering we could have done that today or as well. There was I've been lots of activities today. I've been crazy too, but uh, I felt we should keep up the pace in R because there's a lot to do in R. So the more we can do, we do. The more of my knowledge I can share within this short period, and then just get it done. So as you know, this class is interactive. Everyone is invited to um ask their questions, interrupt me at any points you have questions. So may I ask anyone, does anyone have any question based on any previous classes before we start? Anyone? I don't want to be the only one talking here. Am I audible? Dr. Mali, can you hear me, please? SRS.
Yes, you
Audible?
are audible, sir.
Thank you.
You're audible. Yeah.
Stop acting humble. Thank you.
I
All right. Yeah, and I wanted to hear your voice and hear you laugh, and I've achieved my aims. All right. Okay. Just of us are here in the conference room, so you can always hear me with or without Zoom. Okay. So I guess no questions. Last class, we we stopped at we stopped at line 52. So I believe we've all tried to rehearse all the lines we've done so that you remember because you know it's about how to wrangle data. It's called data wrangling. So we are going to fire on. Any comments from anyone so far? Comments? Okay. So line 56. So this will be the first time I'll have to use a package in our classes. So far, we've been using the base R packages to do our stuff. So today, we are going to use, remember I told you about R, that R, um, R was designed and made open source such that anybody could, edit it, create new things from R and post publicly freely, and people were able to design new things. And that was how. So we are going to use one of such packages called tidyverse. So tidyverse is one very superb package, built by our developers, and it really extends our functions. It makes it easier to work with R. In fact, most of the things that we have that we are doing or we have done using these are ways of wrangling data. It can be done much easier using tidyverse. Tidyverse is a package of packages. Inside tidyverse, there are other dependent packages, sub packages inside tidyverse. So the one I'm going to use here is called dplyr package. So a package can be on its own. Package can also depend on other packages. So when you install tidyverse, you you also install its other dependencies. So I'm not going to run line 57, but I would like everyone to run it because this requires internet connection for you to run this yourself. I've already run it, so I've already installed this package in my R, so I don't need to install it again. So I expect everyone to run it. Please don't open the R and all. Anyway, yeah, this should be interactive. So you can run this R, this 957, then you install package in your R and it's good. And after that, you can now load uh, library tidyverse. So the line 57, what it does is to extract the package where it is online in the canned database of R. Then it download the package into your system and install it. That's what line 57 does. Then line 58 now loads the package into your working memory in your R so that you can now use the package for what you want to do. So let me run my 58, even though I think I have run it before. And okay, just it's mine. And mine, okay, good. So I have just loaded my tidyverse, so you can see what it brought out. So these are, you can just ignore these, but this it tells you the various packages that are attached to tidyverse. You can see dplyr, forecast, dgplot2, lubricate, par, read r, string r, table, tidy r. So these are very wonderful packages that extends our functionality. Then there are also some conflicting um, functions in these packages that conflict with this R. So that is what you see as these conflicts. So it tells you that that where there is a conflict or where there is a function that is same in this R, the tidyverse package, overrides that of the base. So that's why he said this masks this. So there is a base R package called stats. So the filter function in tidyverse will mask that in the start function in base R. You still in the start package in the filter function is in the start package. I'm not speaking so much R uh, jargons. So I'm not confused. But sir, just ignore this. This shows that downloaded the tidyverse package and you are ready to do the work. So to use this tidyverse and what I want to do now will depend on this function, this package called dplyr. So dplyr is a package in tidyverse. So we are looking at line 61. You can see there is this thing I just highlighted. It's called pipe. The pipe function. It's a function in dplyr, okay, that allows you to give a command and use that command to move to another command. To use the output of that command as an input to that command. Okay, so remember our iris data set. If you remember these data sets in R, so this pipe function is like percent greater than percent. So it's called pipe function. It's called piping in R. And we're also going to use this select function too. So what this if we were to run this, what this tells us is, so if you tell R open iris data set and then load it into the next command, and then this command now says select only these three columns: species, subpart length, and then petal length. So let's run this. So you can see this is what this has just done. So if you remember, our iris has more than these three columns, but with this command, we're able to just select these three. Remember, if we are to use the base R, we simply just put iris, then square brackets, then You can put comma, then C brackets, you see total length, but this, you just use the pipe, the select function, and you get the same thing. Then let's go to line 62. Remember, if we are confused at any points, please don't hesitate to call my attention to it. I hope we're not lost. Please, someone should talk. Someone should talk, please.
We are not lost, sir.
Okay. Who else? Dr. Opeyemi, are you lost?
Yes, sir. I'm more than lost.
All right. Dr. Chinyere, please, let's hear from you. How is Joss?
Yeah, yours is fine.
All right. Glad to hear your voice, sir. So I hope you're not lost from what I've been talking so far.
Yeah, I'm lost, but go ahead. I'll catch up.
Wow, everyone is lost. OMG. Okay, except Dr. Chi. Dr. Chibo saying he was not lost. And James. James cannot be lost. I know. James, are you lost?
I'm following, sir. I think I'm following.
All right. All right. And the one and only Dr. Joshua. Let's hear from you.
Following. I'm not lost.
Who else have I not asked? Dr. Mani. Dr. Mani. I know you are lost.
What do you mean? What do you mean? Ah, why are you judging me?
Dr. Mani, I answered the question. Are you lost or not?
You have already answered yourself now. What do you want me to say?
Okay. All right. So,
Why would
okay.
you just say I'm lost?
Well, okay. I'm sorry. Okay. Are
No,
you
no, no.
lost?
I have to know why.
Well, because I don't think you have had the time to go through all our classes. Am I right or wrong?
So I don't want my voice to keep resounding in your recordings. So please, bye-bye.
All right. Dr. CK, let's hear from you.
Good afternoon, sir.
Good afternoon.
Oh, we can hear me, right? Oh, sorry, I came like a little bit late, so I didn't get part of the time class. So I just hope it's not something we need to do to transition for this class or something. Get that pass. And the percentage greater than percentage symbol part, is it similar to the function we target? It's the function where we target each column and use the codenames function. Is it the same function that have a percentage greater than percentage symbols? And it's something.
Okay. Yeah. The percentage greater than percentage is called pipe in R in dplyr. Okay. Dplyr is perfect in tidyverse. It's called pipe function. Um, it's it's a function in dplyr that you know allows you not to boggle too many functions, you know, in a small code, so to say, in a small space. So it allows you to spread your functions so that your coding can breathe. Let me put it that way. Let me give you an instance. Instance can I give? I want to find something that seems a bit complex. Now we can use it to break it down. Okay, I'm looking at line 43. You know, line 43 has a lot, like, iris data sets, then bring up iris, the last part of length equal to this, and this part of this, and then this also column. So with the pipe function, we can, break this thing down. Okay, let's do that. So let's load line 43 and see what it will bring out for us. So you can see line 43. I hope, can someone explain what line 43 means? Let me be sure people understand. Who do I call up to explain this output line 43? 43 and 44, they make up the same command. Though I explained this using the comments section there. Okay. So, but what I want to explain is his or her own language. Who can make an attempt? I'm not calling, please. Someone should speak up.
Okay, let me try, sir.
Go ahead, please.
Okay, so line 43. Okay, the iris is the name of the data set, and then we want to go into iris. That's why we use the $sign to extract part of the data set. So now separ.length is the name of a column in iris. So but we wanted to extract separ.length that is equal to 5.4, and also do the same for iris where beta.width is equal to 0.4. Alongside that, we should also wanted to row 5, 4, and 3. We want to concatenate row 5, 4, and 3. So that is what we are asked. That's what we want to extract from iris. Separ.length where it is equal to 5.4, where beta.width is equal to 0.4. At the same time, do all this within row 5, 4, and 3.
Okay, you said row 5, 4, and 3. Are you talking about that? Row? Can you differentiate row from column?
Sir?
Can you differentiate row from column? What are rows? What are columns?
Okay, rows are each observation from left to right, while columns are the vertical lines.
All right, that's correct. Okay, so you're saying for that command, it is row 5, 4, and 3, right?
Yes.
Okay. Okay. It's totally column. Remember, for base R processing using the square brackets, and a comma inside. At the left of the comma is any expression that refers to row definition. And the right is for column. So actually for column 5, column 4, and column 3.
Okay.
After the comma. Okay. I hope it's not confusing. Okay, so it's for columns actually. So good. So with that in mind, now if we want to repeat this same command using the pipe function, okay, so we can decide to spread it. So now I'm typing on the console. So I'll first type iris, then I'll use the pipe function. Pipe function means move the outputs of what is here to the next command. Now I can ask, then I will want to spread it. Then I'll now say I will use other functions now. So first of all, I have called up iris. Then the next thing now is I will have to use the filter function. So I can say filter. Okay. I will say filter sepal.length equals to 5.4. Okay. And then I can also type it again to another. Then I can also say filter again. Filter again petal dot width equals to 0.4. Okay. Then I can now type again. And I say, okay, just select, that is, give me these rows. 5, 4, and 3. Let's see if this will work. So you see, it worked. But here I spread it. So the pipe function helps you to spread commands so that it won't be so heavy. Looking at, if you remember, let me show up. This was, let me remove these comments so that we can see it better. So, if we look at this, it can be a bit so much. Iris, open brackets, iris, the last of length equals to 5.4, and now to introduce the and operator, and iris the petal the width equals 8.4, comma c open bracket 5.4. So it can be a lot for those who are not so cool working with this R. So the pipe function helps you, calm down and do it one by one. So load the datasets, filter this one first, filter this one, then this one, and gradually, though the command line will be may be longer, but you get the same result. So does that explain to us how what the pipe function can help us do? Dr. Shiki, I think you asked a question. I don't know if if this was helpful to clarify the question.
Yes, sir, very much. Thank you.
All right. Okay, so let's go back. Okay, so line 62. Let me ask Dr. Bayemi, how far does this help you in any way to catch up?
Yes, sir.
Okay, all right. So let's go to line. Okay, someone raise their hands. Dr. James, go ahead.
Mm, I think I was a bit confused with the way the pipe function worked. So I was thinking the more we use it, like the more the pipe function will refer to the last. Let me just use this example to explain. We started with iris. So we used the pipe function and it was like going into iris to filter sepal.length that is equal to 5.4. So the next one, I was thinking it would be maybe if you want to go into sepal.length again, you don't understand, not the next pipe was still referring to iris. So but with what it displayed, I think I now understand.
Okay, yeah, I get your question. So the thing is that um for each of these pipe functions that I moved into, because I didn't specify which columns, it takes everything. It only filters that one, but everything moves to the next one. So until I now read the last one where I now specified which column I want. So it will only filter what I told it to filter, and it won't touch any other thing. It will allow everything to move over to the next one. So like get the question. It's a very nice question. All right. Okay. So line 62. So reference 62, yeah, it's also okay. I introduced the glimpse function. It's also a tidyverse function. And so glimpse. Okay, let's see how it works first, so that I will have to talk too much. Okay, so we see I use the select function to just select columns 2, 3, 4, and 5. Remember, I use this colon operator to indicate 2, 3, 4, 5. So and then I now move everything to now use the glimpse function. So glimpse is like sensors having to have everything listed on our console. So it just gives us a peek of what is in each column, just as we see it appear here. You can see, unlike in this area where we see everything appear, like in normal tabular format, but glimpse first of all gives us the terminal number of rows, number of columns, and then even tells us the data type of each of the data of each of the columns, of the content of each column. Like now, this one is double, species is factor. So everything means factor. So these are the type of data. Double is also is a type of number. Is a numeric factor. Double, we have, remember we have double, long, short, integer. These are all types of numbers. So, glimpse is just a way to shorten your outputs and have an idea of the data structure of the object, so to say, of your output. Okay, so now let's go to another data sets equality. So here we use the equality. We just selected these three columns, and then we now called up the na.omit function. Remember, I've taught this function earlier. The na.omit tells the gives the instruction to remove any row where there are missing values. So if we run this, so we get a lot. So remember, if we run air quality alone, we're going to see a lot of NAs. So you can see there are NA here, and NA in R means not available. That is the missing value. So there are NAs. Okay, but with NA dot omit, we tell it to remove them. Remember, if we have to do this using this R, we have to do na.omit, brackets, air quality, square brackets. We now type the months, day, and months, day, ozone, all in inverted commas. So you see, but with a pipe function, you're able to calmly, spread it out fine. Okay, if I'm to repeat it using this R, I'll talk about type na dot omit, then I'll now type air quality, then I'll now open square brackets. I'll now put comma, mean that's every row. Then I'll now type C, open bracket, open by inverted commas, month, comma, and inverted comma, day, and another comma, inverted comma, ozone. So you see, this is all the same thing as the first one that we did. So, but you see, using the base R functions, you see how it came up. So pipe function just helps you to calm down a bit and type the commands. Okay, so we are now we're now going to line 68. So here we are going to see other functions, what's now how we can now further use the tidyverse packages to even call up more things. So that we are now going to the M sleep data set. So let's build the data set first. Let me use. Then I also want to add that the tidyverse also helps you to avoid issues with view. So you can see you can even use the small letter V. Once you know the library of tidyverse, whether you use capital V or small v, you can always view on your script. Okay. So I can say let's view mflip. So this is our mflip data set. Okay. It's so that is it. I want us to see it first before we start. So now we are now going to use two functions here apart from the type function. So we're going to use the select function and the start with function. So this allows us to use to you know to call up any column that starts with a particular character or characters or string as the case may be. Remember, if we look at the mflip, it has different columns. So it has at this one sleep total, sleep rem, sleep cycle, and others. So by this command, instead of having to start typing sleep total, sleep rem, or sleep cycle, or having to now count the number of the column, you can just use this select and start with sleep. Meaning that any column that starts with the word, with the phrase or the characters sleep, then open it, show those columns. So if we run this, so you can see it only around it won't open the hit total, hit rem, hit cycle. So that's what that's how we can use these statements as select to call up. And then same way too, you can see the function two contains. So contains means contains and start with are different, but they can be similar. If you say contains, you still get the same thing. But content means it could be anywhere in the phrase. It must start with. So it could be in the beginning, the middle, or in the end. But that's what is there. Like now, if you look at the data set again, so WT, you can see there is brain WT and brain WT. So, but this command wants to bring up columns that have both sleep and WT. So if we run this, so you can see the sleep there is there, and then the WT is there. So it helps you to call out specific columns that you want based on the feature of the column names. Where they have similar things, just use that one and it will bring it up for you. Okay. Okay, then here we have the filter function. Yeah, I've already used that earlier on when I was trying to explain the type function as asked by Dr. K. So here you can see the filter function being used. So remember, so let's look at that set again. So we have species. Um, Oh, okay. This is a different data set, Star Wars. Okay, so I use a different data set here, Star Wars. So let's check out what is in this data set, Star Wars. So you can see this is a different data set, Star Wars. I think it's a movie. Yeah, so this shows all the cast and crews and their specific characteristics in the movie. Okay, so that's what this is about. Um, Yep. Okay. Out for that. Three. So now, let me bring this here. Okay, Star Wars. So this that function just wants us to determine to just filter where species is equals to human, or remember this operator here is or, okay, or where sex is female. So and then We're not rather to only bring up only these columns, these name, species, sex, and all. Then we also added we also piped other functions. We turn it view, mean that you want to view the output on the script. So if you run this script, so you can see it just came up on the screen on its own automatically. So this is what we did. Remember what the command was: a human species and female sex. You know, this or this, anyone that inspired any of them, show them up. So human, you can see human or female. So females are human. Anyone I think that that is not human means that it must be female. You can see it's not human but it's female. So you break it up. So that was the command we gave to it. Okay. So so here I further introduce another feature called arrange. You know, arrange allows you to arrange things in alphabetical order. So means you can arrange in different orders. You know, first arrange skin color, then for each skin color, also we are arrange them further in eye color alphabetically. Meaning that let's say each skin color is black, for instance, maybe there are five that are blacks. So inside that five that they will have different eye colors, maybe blue, white, pink. So you know, so that means that the blue will come first before the pink, the white, because that is the alphabetical. So in order. So you know, so we now run this, and I also piped in view. Here it will show up on the script pane here. So and here it is. So remember the arrangement was skin color first. So skin color will be the first to be arranged. So based on skin color, so you see blue, brown. Okay. So you can see among all the ones that are brown. So we also told you to arrange them based on eye color. So you see blue comes before brown, before yellow. So you see it's obeyed our instruction. Okay. Okay. So we are now going to okay, any of omit. So this I've already done this before. So use any dot omit to remove rows with missing values. So you can also use any dot exclude. Yeah, you can use any of them get the same output. And then we have this. Okay, here I could use drop underscore any. So this is a function that allows you to uh, remove based on a specific column. So it means that okay, there I would extract the cases everybody in the hair color columns only are removed. So it means that unlike any dot omit or any dot exclude, where it tells us that any row where there are missing values, please remove that row. But drop underscore any function tells us just focus only on the hair color and because it's specified hair color. Wherever there is the missing value, remove that row. So focus only on the hair color. That means that you may still find missing values in other columns. Okay, so let's run this. Yeah, thank you. Now, I'm thinking that I should add view. Let me pipe view into it so that we can see it on the script better. So let me pipe view. So let's see. You can see there are NAs in other places, but for hair color, we don't see any NA because we have removed all the missing values based only on hair color. So I hope that is clear. So any questions so far? We're done with this short script so far. Any questions from any quarters? If none, I already have a fourth script that I was preparing. I'm not finished, but I think I will just I'll wrap it up and send to the group. So maybe let's just start on this first script. Later, when I finish sending it, I'll send it to the group for us all to follow. Okay, so I started here with the subset function. So you know, in R, there are thousands of commands, and sometimes there are many commands that can do the same thing. So subset is a base R function. You know, it's or similar function to select and the square brackets and the dollar sign. You can use, so now we are saying subsets. We have now added comments to this one, so I'll do that later on. So subset function here, it tells us subsets for Star Wars where hair color is equals to brown. So if we run this, so you see only hair color equal to brown and rows are shown. Okay. Here I now added hair color brown, then select equals to, so I now limited the columns that are to be shown. So if I run this second one as well, so I limited the column that will be shown, only name, hair color, and eye color. So these are commands under the subset function. Okay. Now I now went to another one where we will use the minus operator. Remember, the previous ones we've been using function that will help us select functions, so select columns. So we also have operators that will help us to remove what we want. You can use any of them. You can achieve something depending on what you have in front of you. So you can use the minus sign to remove. So you can decide to just say, I want these only. You can also say, remove all these ones around. You see, there are two ways of doing something. Just like having having a cup. Someone will say, maybe the cup, the water is on the half place. Someone will say, this cup is half filled. Another one will say, this cup is half empty. It's the same thing. So same way here, instead of saying select this one, can say remove this, that, and of course it left with the same thing. So with the minus operator, here now we can this command here means remove columns 10, 11, 12, 13, 14. So, but you know, I also introduced the assign the assign function here. You know what you used to assign. So we are needs to also create an object called Star Wars and save this in this. Remember, this Star Wars is only in the memory as the data set. So that means we will override the Star Wars data set with this new one, and it will not appear in our environment. So if we run this, you can see we now have Star Wars here, and it only has 9 objects. So if we click this to see it, you can see it has reduced. I can no longer scroll to the left. It only has 9 columns because that was the command gave. And you can also tell it, okay, this same as above. Remember, we did this in the previous classes where you can use comma to denote rows and then columns. I'll just use column to one. So this is still something that will happen. Okay, but this may not work because we have already reduced the number of columns here to 9. So if I should run this script now, I'll get an error because I don't have up to 10 to 14 columns. You know, this should be based on the original data sets. So if I run this now, you see I get an error because you know there are no this number of rows except if I will come back to the original one. I can use the data function data Star Wars to restore the original one. Then I can now run this. Then it will work. So you see, and if I want to view the Star Wars, you can see something 9 columns. Okay, I hope you're following. I hope I'm not abandoning you guys. Are we following? Hello? Or maybe you guys will say
Yes,
we
sir.
want to be okay.
Yes, yes.
Yes, sir. We're following.
All right. Okay. Okay. So okay. So now we go to line 18. So you see this now tells to delete uh these specific columns, column 1, column 5, column 3. This one too is something using the comma to delineate the rows, delineate all rows. Then this will be number of columns to be removed. So because of this minus sign, it removes, deletes them. Then here, okay, I introduced this function which, okay. I think I've also done that in the previous ones where I use which to also, because which brings up the position of whatever we are asking R to do for you. So we are simply asking R to remove rows. Remember there is a comma here, I mean that's all columns because there's nothing here. So all columns, but remove rows only where Star Wars gender is feminine. Okay. So let me load back our original Star Wars data set in our global environment. And then if I now run this, you will see that only feminine will show for our gender. Okay. So I've run this. So if we go to our Star Wars, you can see um gender. Where is gender? Uh Gender. Okay. Right on it. Star Wars. Okay, yes, I said remove. I was really looking for feminine. So I remove feminine. So I mean everything here will be other feminine. So you can see masculine, you can see NAs, only. So removed. I was busy looking for it. So definitely remove because of that minus sign. That means that if we remove the minus sign, only feminine will remain. So let's try that. So let me return the original Star Wars and then remember I'm working here from the console. If I remove this minus sign, it changes everything. So if you take our Star Wars, you see only feminine will be here. Can you see that? So you see just that's minus sign is what changes everything based on the command that we get. Okay. All right. So okay, this will the original data set. So there are many ways to load the original data set. You can decide to use data Star Wars. I mean decide to say RM. I think I've done that before. RM is to remove from the global environment. So if you say RM Star Wars, it's still kind of it turns back to the original Star Wars data set. Okay, so that's all for this one. Any question? I want to go to the next one. I'm really moving quite fast, but I hope I'm not rushing. Even though I know I can really go back to this video, but there is need for I don't want to be carried along. So any questions so far? Anyone? This is 4:27. We have just 3 minutes. Okay, so now I want to go to a new dataset called Indomets. So let's look at this dataset. If I should open it, you can see this is Indomethacin. It's a study. I don't know if we should go ahead because I'm here. Okay. I'm introducing. This is how to add columns to variables, how to add columns to a data set, or how to compute, from existing columns to pick up a new column or to add. Um, I'm thinking I should stop here because of time. We're supposed to stop at 4:30. Okay, let's just load these data sets first in our memory. And so this is a study where this drug indomethacin was given to subjects. See, and at different doses or concentrations and at different times. So this is the result of the study. Okay, so all these subjects refers to different individuals. One, you got two, 3 and 4 and 5. So now you will decide to add a column called indomethacin. No, the column is called drug, but we'll pick up with this. So if we load this, and then we now load back our indomet, you can see we have added one column variable, title drug. I can see this thing indomethacin. So that's what this line that the two just did. So now we can also add another column called drug 2. So that we use the mutate function. We use the mutate function in tidyverse. So if I load this, then I return back and load it. So it adds its indoor. So these are different ways. So this used this R, why this used tidyverse. Okay, I think we'll stop here. It's only 4:30 p.m. So any other questions, comments before we wrap it up? Okay. So in the absence of any other, thank you all for your attendance and attention. So we'll meet again next week. Thank you. God bless.
Thank you, sir.
Thank you, sir.
Thank you, sir.